So talking about moving lights and moving light addresses and how many addresses they need, and we said that even a simple moving light might take 15 to 25 addresses. And let's look at a simple moving light system and how it might get connected. So if each parameter requires an address or a dimmer, let's look at our little example down here. And I've chosen the simplest of intelligent light of device, and that's an RGB, a color changing red, green, and blue fixture. It has 3 colors of LEDs, one red, one green, and one blue. And that device, it's all one fixture, and it requires 3 addresses. And when I turn on the first address, the red lights turn on. And when I turn on the second one, the green lights turn on. And the third one, the blue lights turn on. Right? So when I am setting my system up, this device would be given a start address of 1. Right, which is the first address that I wanted to respond to. Just like a dimmer rack, it will automatically assign the next 2. It will assume, right, and you can't alter it, that address 2 is going to be green and address 3 is going to be blue, right? It assumes that, right? So that means that this device has a DMX footprint, right, of the number of DMX addresses that it needs, a DMX footprint of 3, right? So there's going to be 3 addresses for each. Now, we run our DMX cable, we daisy chain it into our next device, and our next device, it can't overlap with these, right? If I were to set this, give this device an address of well, we should just give it an address of 4. We should go ahead to the next available address, which is 4, right? Which means that the red is going to respond to address 4, the green to address 5, and the blue to address 6, right? So the first, right? And now we daisy chain to our next one, and we set its start address at 7. So 7 for red, 8 for green, 9 for blue. Now, if we set our next fixture at 8, we will see that we'll overlap, right? So when I turn on address 8, I'm going to get green on this device, and I'm going to get red on this device because they overlap. They're sharing an address, and we can't do that. Now, when we're patching, oftentimes, for simplicity's sake, we will do something called hotel patch. I don't have to use every DMX address in the path. So I can skip numbers, right? I could set this address as 1, and so 1 controls red, 2 green, 3 blue. And I can set my next device's address at 11. So 11 red, 12 green, 13 blue. And the next device address at 21. So 21 red, 22 green, 23 blue, and so on down the line. So any number ending in a 1 is going to be red. Any number ending in 2 is going to be green. Any number ending in 3 is going to be blue. It's a way that we can sort of simplify in our brains what our addresses are. Let's look. Right, so we quickly run out of DMX. DMX 512 supports 512 addresses. And if I have moving lights that require 60 DMX addresses, you can see that I'm only going to get, I don't know, maybe 10, no, 8, 7 devices on a DMX path. And that's not very many. So we need a way to be able to get more addresses. And the way that we get more addresses is by essentially adding what's called a DMX universe. It's another cable. It's a second DMX cable that comes out of the light board, runs all the way back to the light board, right? And And that second universe also has just 512 addresses available on it, right? So if I look at my universe 1 patch down here, my first device is going to be at address 1, address 11, address 21. But now I've added a second universe, and the way that the second universe is separated at the light board is the light board counts the second universe as address 513 through 1024, the next group of 512, right? And universe 3 is 1025 through 1536, which is the next group of 512. Okay, but the devices that are along the DMX path, they can't read anything above 512. So they have to be addressed between 1 and 512, even though they're on universe 2. So my first device is going to be an address 1, but it's connected to universe 2. My next device is going to be address 11, but it's connected on universe 2. And the light board makes this translation for us, right, between what the universes are, right? And so the light board is treating this as address 513, address 523, address 613, based on its address. But the device needs to be addressed at 2/1. So an RGB fixture with a start address of 1 on universe 4 would be notated as 4/1, or universe 4 address 1. And it would be using DMX addresses 1537, 1538, and 1539. 1537, 38, and 39, the first 3 addresses of the 4th universe. Shows can be very complex. A really large show may have hundreds of DMX universes. So these numbers can get really big really fast. And so manufacturers have provided us with this 2/ or 4/ so that us stupid little lighting people only ever need to count to 512 and then just know what DMX universe we're plugged into. So that's a little bit about DMX. Now we're going to dive into the actual fixtures.